Let's take a look at joint variation. We've already studied direct and inverse variation. This really isn't something different. Instead, it is a form of direct variation where if one variable increases, the other one will as well, or vice versa. If one decreases, the other will also decrease. The difference here is I might say y varies jointly as x and w. I don't use the word directly, I just say jointly, which implies direct variation. Here's a practical example. In chemistry, we know that the pressure and volume of a gas vary jointly with the temperature of that gas. All right, that will give me my first part of my solution. I'm going to make the general equation T, my temperature, is equal to K times PV. You could have put PV equals KT. That would give you the same thing, except you get a different K. That part doesn't matter because that's not what my final answer is going to be. Okay, so you can set it up either way with a K on either side. Now I know that I have 35.4 milliliters of hydrogen gas at 24 degrees Celsius with a pressure of 745. Well, I'm going to plug that in to my formula and then solve for my K, that constant of variation. To do that, I would divide both sides by that product of 754 times 35.4. And when I do that, I'm going to do it all in one step in my calculator. So 24 divided by, and I'm going to use a parenthesis to indicate that all of this is in the denominator, and just simply 754 times, not another parenthesis, just times 35.4. I'll close that up. And then I get this kind of weird looking answer. Make sure you read the entire line. At the end here, it has this e to the minus 4. That means scientific notation. In other words, 8.99 blah, blah, blah times 10 to the negative 4. When you multiply by a power of 10, you're moving the decimal point. If it's a negative, that means we're going to make this number smaller and move the decimal point backwards or to the left 4 places. Doing so would get me this answer here, approximately 0.0009. All right, now to answer the question. We want to know what the volume is if we reduce the temperature to 10 degrees Celsius and the pressure to 700 milligrams of mercury. Well, I'm going to take those numbers and put them into my formula. Right, so I've got my T equals with my constant of variation times PV, and then I plug in the new information, and once again I will divide both sides to solve for the V, and in this case I get approximately 15.9 milliliters. Let's take a look at a just basic problem without any context. If I say that y varies jointly as x and the square root of z, and inversely as the cube of t. So I'm saying y is equal to some constant of variation because it's jointly times the x and the square root of z. Because I've got an inverse part here as well, I'm going to put all of that over t cubed. I only need one constant of variation. I don't need to have one for each of the variables. We're just going to find one that works for all. Just as in the last example, we'll plug in the given information to solve for k, and when you do that, you should get k equals 4. Then I take this and I plug it back into my general formula, and I get this first step here in number 3. Now I take the given information on the last sentence and plug it in to find the y. So when I do that, I come up with 3/2. Let me know if you have questions.